Hi there, and welcome to this next video in this Integrated Math 2 video series. In this video we're going to talk about how to convert from standard form to vertex form of a quadratic using something called completing the square. Before we get into that, let's go ahead and do our warm-up for today. So we have these 4 problems here, so take a moment and see if you can try those 4. Alright, so in number 1 here we're going to convert from factored form to standard form is what it's asking us to do there. And to do that, we need to use what we did a couple of videos ago, using operations with polynomials to multiply this polynomial out. So we're going to, again, there's a number of ways you can do this one. I'm going to multiply these 2 together first and then multiply the result by the 3. So when we multiply these 2 together, we're going to get x times this whole set of parentheses. So we're going to get x times x is x squared, and x times 4, which is 4x. Then we're going to multiply the negative 2 times this whole parentheses and get negative 2x and minus 8. So we have this whole thing times 3. You can go ahead and combine like terms here if you wanted to before you multiply by the 3, or you can wait till afterwards. Either way is fine. So this is equal to, this is equal to, let's see, we're going to have 2x in here, right? 4x minus 2x. So 3 times x squared is 3x squared. 3 times 2x is the 6x. And 3 times negative 8 is negative 24. So we've converted it from factored form to standard form. Now these are equivalent. You see the equal signs here. It's an equivalent form, but just written in a different way. All right, so from there you can tell like the y-intercept, you can tell the concavity, which I guess you could anyways here, but you can definitely tell the y-intercept and the a, the b, and the c. All right, number 2, if f of x is x divided by 2 squared, what is f of negative 6 and f of 8? So what that's telling us to do is to substitute negative 6 in for the x and see what we get. And then substitute 8 in for the x and see what we get. So if we substitute negative 6 in, we're going to have negative 6 divided by 2 squared. So we're going to divide by 2 first, and then do the parentheses, so then we're going to square. So negative 6 divided by 2 is negative 3. Negative 3 squared is 9, right? Negative 3 squared, in parentheses there, will be negative 3 times itself. So negative 3 times negative 3 is a positive 9. All right, whereas if we do f of 8, that's going to be 8 divided by 2. Squared. 8 divided by 2 is 4. 4 squared is 16. All right, number 3, find the average rate of change of f of x, so this function up here, over the interval from negative 6 to 8. So if you remember, average rate of change is really just the slope of the secant line between the 2 points. So if we were to travel at a constant rate but in between those 2 points, then what would the slope of that line be? So really what we've got here is we're going to find the slope between negative 6 comma something and 8 comma something. The great thing about these 2 problems put together is we've already found the y values for negative 6 and 8. So for negative 6 that was 9 and 8 that was 16. So to find the slope between 2 points, we're going to subtract their y value, so 16 minus 9, divided by subtracting their x value, so that's going to be 8 minus a negative 6, which ends up being a plus 6. So it's going to be 16 minus 9 is 7, over 8 plus 6 is 14, which is going to simplify to 1/2. So the average rate of change in between negative 6 and 8 is 1/2. Okay, so from there, we're going to look at number 4 here, to factor 12x squared minus x minus 6, which we talked about a couple of videos ago, how to factor something like this. And we talked about factoring by grouping. And so the first step in factoring by grouping is to separate this middle term into 2 terms. And the way that we find out what those 2 terms are is to multiply a times c. So it's going to be negative 72 And this is our new value that we're trying to multiply to get. So we're trying to think of two numbers that multiply to give us negative 72, that add to give us negative 1. So if you then go through all the possibilities, what multiplies to give us 72, one that might come to mind is 8 times 9. And to add to give us a negative 1, we need the 9 to be negative, right? Negative 9, positive 8 gives us negative 1. So we're going to rewrite this as 12x squared minus 9x plus 8x minus 6. All right, so we still have 12x squared minus 1x minus 6. We haven't changed it, we've just rewritten it in this way so that we can group the first two terms and the last two terms and factor out what we can from each. So we can factor out a 3x from the first two terms, leaving us with, let's see, 4x minus 3. Then we can factor out a 2 here, leaving us with 4x minus 3. Again, a great indication that we're on the right track here is that what's in parentheses match. From there, we can factor out what we can from the entire expression. So what's in common here and there is the 4x minus 3. So we can factor out a 4x minus 3 from the entire expression, like a GCF, and that leaves us with 3x plus 2 left over when we factor out that factor of 4x minus 3. So that's the factored form. Again, there are multiple ways to do that. I like factoring by grouping, but you may have a different strategy there. So that is the factored form of that quadratic there. All right, so as we get into our lesson for today, our goal is to use something called completing the square to convert quadratics from standard form to vertex form. So completing the square is just the strategy that's used to convert from standard form to vertex form. So let's kind of recap what we've done so far. So we've got our three forms. We have standard form, which looks something like this. We have vertex form, which looks something like this. And we have factored form, which looks something like that. And we want to, as we'll see in our next video, we want to be able to convert between the three different forms to find out key characteristics of a quadratic. And so there are ways that we can navigate that and go between the forms. So let's recap here. So to go from vertex form to standard form, we can just multiply out this squared term and combine like terms. So it's quite simple. Just multiply, right? Multiply this out to get from there to there. To get from standard form to factored form, we factor, just like we did in number 4 in the warm-up. To get from factored form back to standard form, you multiply it out. So just multiply, right? This out. And that'll get you standard form. To get from factored form to vertex form, you could multiply it out to get the standard form, and then do something here that we're going to talk about today called completing the square. The other option to get from factored form to vertex is to average the roots. So if you've got two roots here, R1 and R2, you average those. That'll give you the axis of symmetry, which is also the x value of the vertex. So that allows you to find h, and then of course from there you can substitute h back in to find the k value, and now you've got vertex form because you've got your h and your k, and then of course a is the same as the a over here. So you've got all the components of vertex form that you need. So we've got a missing component here, which is from getting standard form to vertex form. You might say we have also missing one from here to here, but what you could do from vertex form is to multiply that out to standard form and then factor to factored form. And so you can get there, you just got to go through standard form. All right, so let's get into it. Let's talk about how to complete the square to get from standard to vertex form. All right, before we do that, or I'd like to introduce you to this idea, I want you to try to factor these 5 and see what you get. All right, so if you factor these 5 here, hopefully you'll start to notice a pattern. All right, so let's go through each one. This first one factors to x plus 3 times x plus 3, which is x plus 3 squared, right? Anything times itself, right, is x plus 3 then squared. The second one here, it would be x plus 5 times x plus 5, right? Because 5 plus 5 is 10. 5 times 5 is 25. Equals x plus 5 squared. All right, for the next one, x squared minus 8x plus 16. Let's see, it's going to be x minus 4 times x minus 4, which is x minus 4 squared. This next one, x minus 1 and x minus 1, which is going to be x minus 1 squared. And then lastly, x plus 6 times x plus 6, which is x plus 6 squared. So you notice that every single one of these resulted in a perfect square. Right? All of these end up with some parentheses and then squared. So they all end up in a perfect square. So that's our goal for today, is to be able to convert something from this form to this form. So we need to know when does that happen? In what situations do we get something like this? So we need to examine the quadratics over here. What do you notice about these quadratics over here? Specifically, I want you to look at what's the relationship between B and C. B and C throughout. What is the relationship? Is there any way, given B, is there a way to compute C? Given B, is there a way to compute C? So take a minute and look at that the pattern here and see if you can figure that out. All right, so hopefully you're seeing that if we take B and divide it by 2, so 10 divided by 2 would be 5, and then square the result, so it'd be 5 squared is 25. Here it'd be 3 squared is 9. Negative 8 divided by 2 is negative 4. Squared is 16. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. 12 divided by 2 is 6. 6 squared is 36. So for each of these, the C value was the B value divided by 2 squared. So that's the relationship here, right? The C is equal to B divided by 2 squared. That's what we need to happen here, right? Is that relationship. This needs to be true in order for it to result in a perfect square like that. Okay? So just fill in the blank here real quick. X squared plus 14x plus blank. What could we put in the blank so that it would factor to a perfect square? All right, so hopefully you're thinking, okay, well, if I take B, which is 14, and I divide it by 2, and then square it, let's see, 14 divided by 2 is 7, squared is 49. And yes, that is correct. 49 would need to be in the blank in order for it to factor to a perfect square, which hopefully you're thinking, okay, that perfect square is going to be x plus 7 squared, right? Because 7 and 7 add to 14, 7 and 7 multiply to give us 49. All right, so I want to give you a visual of this as well. In this case, we've got x squared plus 6x. And we want to think about what value would we put in the blank there that would complete the square. So when we say complete the square, we're literally completing the square. So we've got 1x squared, which is a box of side length x by x. So x times x, the area of this is x squared. And then we have 6 x's. So each one of these has an area of x, right? This length here is 1, and then this width here is x. So the area of this is x, 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 x. So we have 6 x's. So what's been done here is the 6 x's has been split in half. So 3 here and 3 there, to create the origins of a square. Okay? So what we're going to think about is how many unit tiles, so how many green squares, this is a 1 by 1 square, how many of these would fit in here? And you're probably thinking, well, 3 times 3 would give us 9 of those squares that would fit in there. And that's exactly right. So you would need 9. I'll try to draw this here real quick. So we have this in red, I guess. So you get the point there. So there's these 9 that we're going to have to add to that. And I want you to connect it to this whole idea of b divided by 2 squared. All right, what we've done here, we've taken b, which is 6. We've divided it by 2. So we put half of it here, half of it there. And then that length, the b divided by 2 length, becomes the side length of the square that we need to build in order to complete the larger square. So the number of tiles here that we're going to need is b divided by 2 squared. So we're going to need to add 9 to the blank here in order to literally complete the square. Well, what's the area of the square now? Instead of thinking about it as a bunch of individual areas, what's the area of the entire thing? Well, what's this whole side length here? X plus 3 is this whole length. Across the top, x plus 3. So we have a square of side length x plus 3. So the area is x plus 3 quantity squared. So this is equal to this. So this is the sum of all the areas individually. This is the area of the entire thing put together there. So anyways, that's just a visual of how completing the square works. We're literally completing the square if you think about it using algebra tiles. All right, so let's go on and see what we can do, because the whole point of this is to be able to convert from standard form to vertex form. So it says convert, it should say it's off the screen here, to vertex form and write the coordinates of the vertex. So let's convert to vertex form, and that'll allow us to find the coordinates of the vertex. All right, so as of right now, will this quadratic factor into a perfect square? Hopefully you're saying no, right? If we divide negative 10 by 2, we get negative 5. Negative 5 squared is not 7, right? What we need there is a 25, and what we have is a 7. So here's the strategy that we're going to do. We're going to rewrite this. So y equals x squared minus 10x, and we're just going to make it happen, right? We're going to make happen what we want to happen, and then just compensate as a result. So we wanted a plus 25 here, right? Okay, well, let's do that. Let's just put the 25 in, but compensate on the outside. So I'm going to put this in parentheses. I'm going to group that part together, that part that's going to build that perfect square. I'll put that in parentheses. And then if I add 25 to compensate, I'm just going to subtract 25 out of here. And that'll go with the positive 7 that was there in the beginning. So you're probably thinking, why would we want to do that? Well, we're not changing it, right? Positive 25 and negative 25 is 0 essentially, right? So we're basically adding 0 to this. So we're not changing it. We're just writing it in this way so that we have a perfect square here, and then on the outside we've got some stuff left over. All right, so let's factor the parentheses here. So y equals, let's see, x minus 5 squared, right? Negative 5 and negative 5 add to give us negative 10, multiply to give us 25. And then all we need to do is add these together here, and we'll get our value on the outside. So that's going to be, let's see, negative 18. And now all of a sudden we've got vertex form, right? This is the vertex form of a quadratic. So from there we can actually find the vertex. Remember, the vertex is whatever makes this 0. So what x value would make the parentheses 0? So that would be 5, comma, and then if we do put in 5, we're going to get 0 here, squared is 0, so 0 minus 18 is negative 18. So the output, when we put in 5, is negative 18. So it's whatever makes this 0, comma, and then it will always be this value on the outside is the y value. All right, let's try another one. All right, let me give you a second to at least attempt this one and see what you can do. All right, so on this one, we're going to do the same thing. Y equals x squared plus 20x plus blank. So we're going to build that perfect square inside the parentheses here. So what needs to go in that parentheses or in the blank? Let's see, 20 divided by 2 is 10. 10 squared is 100. So we're going to put 100 in this blank here. And as a result, we're going to subtract 100 on the outside to go with the negative 3 that's already there in the beginning. Okay? So then we can factor. So it's going to be x plus 10 squared. And by the way, it will always factor, this number here will always be half of b. It'll always be half of b. So yes, you can think about factoring it, but really it's always going to be half of b. All right, and then minus 103. So our vertex is negative 10, comma, negative 103. All right. So before we get into the next piece here, because we're going to have a little bit of a caveat to this when a is not 1. So far we've only been dealing with quadratics with an a value of 1. So before we get to that though, I want to pose this situation, and you'll see why I'm doing this here in a second. But 23, could we rewrite 23 as 23 plus 4 minus 4? That's 27 minus 4, right? Is that still 23? Yes. Could we write it as 20 plus 3 minus, 23 plus 3 minus 3. Yeah, same thing, right? Or 23 minus 7 plus 7. Same thing. So that's what we've been doing, right? We've been adding something to the inside, but subtracting it, or at least doing the opposite sign on the outside. That's all we've been doing. So hopefully you can connect this to what we've been doing and what we're about to do. All right, so let's try this one. So this is, again, a different situation, but we're still going to do the same thing. We're still going to have the same goal in mind. All right, so the first thing we're going to do is build this perfect square. All right, but by doing that, though, we're going to isolate that plus 5 off to the side. We're not going to worry about it yet. We're just going to complete the square, build that perfect square trinomial with the first 2 terms. So these 2 terms here. Okay? So to do that, we're actually going to need to convert it into a situation that we've already been working with, which is an a value of 1. To get this to be an a value of 1, we need to factor out that leading term, the leading coefficient in front. So it's a negative 3. So I'm going to factor out a negative 3, leaving us with x squared minus 8x. So to check yourself, multiply the negative 3 back in. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 8 is positive 24. Okay, so it works out. That's a great way to check yourself. Okay, so now inside the parentheses, we've got the situation that we want, right? We've got an a value of 1 right here. So we can complete this square as normal. Okay, so negative 8 divided by 2 is negative 4. Negative 4 squared is 16. Okay, so we factored out the leading term or leading coefficient, and then we completed the square on the inside. But the compensation, here's where it gets challenging. The compensation you've got to be really careful about. Okay, here's what I mean. This 16, you might say, okay, well, let's just subtract 16 on the outside. But this 16 here is not really just a 16. Okay? Everything in this parentheses is being multiplied by what? Negative 3, right? So when I put 16 in here, I'm actually putting in a negative 3 times 16, which is a negative 48. So as a result, so this negative 16 is really negative 48, so minus 48. So to compensate that, I need to add 48 on the outside. Okay? So take a minute and just pause and think through that step for just a second. All right, so just to recap. We completed the square with like normal in here, but we had to think about what we actually added to the function. All right, because of that negative 3 on the outside. Negative 3 times 16 is negative 48, so we had to add 48 to compensate. All right, so from there we can factor the parentheses. Again, it's always going to be half of b, so negative 4 squared plus 53. So therefore, the vertex is positive 4 and 53. All this negative 3 does is it makes it concave down, makes it open downward, and vertically stretched a little bit, which makes it a little bit skinnier. All right, so let's go ahead and try one of these. Take a minute and see what you can do here. Remember, push that negative 11 off to the side for now. We'll come back to it later. Factor out the leading coefficient and then complete the square. Just be careful with your compensation. Okay, so in this one, again, push the negative 11 off to the side, and let's factor out the leading coefficient with the first two terms. So it'll be 7 times x squared plus 6x, and then now we can complete the square. So 6 divided by 2 is 3, 3 squared is 9. You should recognize this one from the visual that we did a few minutes ago, and literally completing the square there. All right, is that just a 9? No. No, it's actually, everything in here is being multiplied by 7. So really what we have here is 7x squared plus 42x plus 63. Okay, so we need to think of that 9, not as a 9, but as a 63. So we're going to subtract 63 on the outside, giving us a final vertex form of 7 times x plus 3 squared minus 74. So that means our vertex is going to be negative 3, negative 74. So this is vertex form here. It allows us to see the vertex pretty easily, which is there. Okay, so completing the square, again, continue to practice that and work on that strategy. But there are other methods. One of them is to graph graph the quadratic in standard form and find the vertex, and then convert that back into vertex form. So, for example, we have x squared plus 17x minus 4. Right away, I'm thinking, this is not going to be easy to complete the square, because think about this. You're going to have to half 17, right? This is not an even number. So when you half it, you're not going to get an integer, you're going to get a fraction. And then you're going to have to square that, and then compensate. It just kind of gets hard from there. So think about graphing this. All right, you can do this on Desmos or on your graphing calculator. And let's see here. And I've got a graph here. So on Desmos, you could just hit the button down here where the minimum is. That's our vertex. And you get negative 8.5, 76, negative 76.25. So that means that our vertex form would be x plus 8.5 squared minus 76.25, I think is what it was. Yep. Okay, so we just converted it from standard form to vertex form just by using our calculator. All right. In the next unit, we're going to talk about another strategy. There's actually a formula that you can do to get from here to the b value or the h value here. So there's a formula that you can do, but we're not quite ready for it yet. In our next unit, we'll talk about a formula that can be used to get h really quickly from standard form. All right, in our last example here, we have kind of a real life situation. We're given a function in standard form. So this is a model rocket's launched from the top of a hill, height of 60 feet, which is why this is 60, right? That's the initial height. This gives the height after t seconds. Write an equivalent form of the equation to reveal the maximum height. So the maximum height is going to be the vertex, right? So if we think about our graph here, it'll look something like this, and then our maximum height is up here at the top. So we want the vertex of this situation, this quadratic. So what we want to do is we want to complete the square. So we're going to start with, and you can use y if you want to for now, and then convert to h of t later, or you can just use h of t and then go from there. Either way. So you have negative 3 t squared plus 12t plus 60. All right, so take a minute and attempt to convert this to vertex form. Okay, so the first thing to do is to push off that positive 60 to the outside. We're going to come back and bring it back in later. For now, we need to factor out the negative 3 from the first two terms. So that's going to be t squared minus 4t. Again, double check yourself. Negative 3 times t squared is negative 3t squared. Negative 3 times negative 4 is positive 12. And so from there, you can complete the square. It's a plus 4. I'll do some blue, plus 4. But it's not really a 4, right? It's a negative 3 times a 4, which is negative 12. So I'm changing it by negative 12. So to compensate it, I need to add 12 on the outside. So that's going to give us h of t equals negative 3 times, let's see, this factors into t minus 2 squared plus 72, which gives us a vertex of 2, 72, which means after 2 seconds, right, t was seconds, right? After 2 seconds, the maximum height of the rocket occurs, and that is 72 feet. All right, so that helps us convert there using completing the square. Obviously, you could graph it and try that as well if you're given a calculator. So that's a real life example, and we're going to look at this more in our next video, converting between different forms of a quadratic in real world situations to find out characteristics about that situation. And so hopefully you'll be able to watch that video as well. But all in all, that was our goal for today, was to just convert from standard form to vertex form using completing the square. And then we also shared some other strategies such as graphing, and then of course the formula that will come into play in the next unit. All right, so hopefully you'll join us in our next video. We'll talk more about converting between the forms of a quadratic.